Okay, today we're going to look at scatter graphs and in particular correlation on scatter graphs. Scatter graphs are a way of comparing two variables. We plot the two variables and we look for a connection between the two variables and we call that correlation. I've got 7 scatter graphs here to demonstrate what correlation will look like on the scatter graph. So if we take this first example, as variable A increases, so does variable B. And we call that positive correlation. As one increases, so does the other. We can see on this second scatter graph here, as C increases, as the scores get higher for C, they also do for D. So this is also an example of positive correlation. The third scatter graph here, as the values of E gets bigger, as the points get further up the E scale, they also get further along the F scale. So these 3 are all types of positive correlation. The difference in them is the strength. This first one is a dead straight line, that's perfect correlation. This one's an obvious pattern, we'd call that strong positive correlation. And the third one is much weaker with a point here that doesn't really fit. We'd call that weak positive correlation. The next 3 scatter graphs all exhibit negative correlation. So if you look at this one here, as variable G increases, so as you get a high value of G, you've actually got a low value of H. So as G increases, H decreases. When you get a high value on the H axis here, you've got a very low value on the G axis. So as H is high, G is low. This is what we call negative correlation. This is a dead straight line, so that's perfect negative correlation. J increases as K decreases. So this once again is negative correlation. That's strong negative correlation. Points are a little bit more spread out here, but it still follows that negative pattern. So these 3 are examples of negative correlation. The final graph here, N and against P, you'll see the points are randomly scattered. That is showing that there is no correlation. So whatever those 2 variables represent, there is no connection between them. They are just a random collection of points. There is no connection between those 2 variables. When we have correlation, we can draw a line of best fit. And that's a line, a straight line, that goes through the points and follows the pattern. Very easy to draw with perfect correlation. With strong positive and strong negative correlation, you would use a ruler, of course, but you get the points going alongside the line of best fit. Not as easy to draw with weak correlation, but you can see we can still draw a line of best fit that roughly follows the pattern, but you cannot draw a line of best fit when you have got no correlation. So the correlation is all about how the variables connect. So positive correlation, the variables, as one variable increases, so does the other. With negative correlation, as one variable increases, the other decreases. And with no correlation, there is no connection between the 2 variables.